Hello, everybody. Welcome back to another video. In this video, we're going to be taking a look at an MCQ question from the IB Chemistry Paper 1 Nature from November 2016. And this MCQ is to do with the emission spectrum for hydrogen. Now, such questions come up quite a bit in exams, especially to do with emission spectrum. This is from topic 2. It's a small part of that, and it is quite an important concept to understand. And really the main concept, the foremost thing you need to understand is that electrons in an atom, right? So imagine I have some random atom over here, okay? I don't know what it is. It's some element. I'm just going to call it element S. Oh no, that already exists. I'm just going to call it element X, okay? It's some random element. I have just made it up right now. It has one electron in this shell over here. Its first shell, it has one electron, and it has all these other shells, okay? So this electron here, this electron is obviously closest to the nucleus. This is the nucleus over here. This is the nucleus. So the electron which is closest to the nucleus has the lowest energy. So this shell, this energy shell, this is the first shell, right? This is the first one. This is the second one. And this would be the third one. So naturally, the electron which is closest to the nucleus will have the lowest amount of energy, right? Because it's so close to the nucleus, it's going to have very little energy because of the force of attraction of the nucleus. However, if we suppose provide enough external energy to this electron by heating it, for example, this electron can temporarily be in this excited state. So it might get a bit excited with this extra energy it has got, and it may be able to transition to the next shell. It may be able to move to the next shell. Oops. So now it's moved here. Now, in the second shell, the electron obviously is going to have slightly higher energy than what it had in the first shell. That's natural, right? Because it's now further away from the nucleus. And then the third shell will have the highest energy in this case. And hopefully you get what I mean. However, this electron will not always remain in this state. It won't always be able to remain at this high energy level. Eventually, it has to return to where it originally came from, and that is the first shell. So eventually, it's going to drop back down, right? And when it drops back down, when this electron drops back down, when it returns to its home, it's going to emit some energy. It's going to give out some energy because it's losing it, right? The energy that it needed to get to the second shell is going to give that away, and it's going to drop down back to the first shell. And that energy that is given out, that the specific energy, can actually correspond to a certain color being shown on a spectrum. And that is exactly what this is. Emission spectrum. That is the energy given out by an electron when it is transitioning from a state of higher energy to a state of a lower energy. And these colors we see, this energy we see as colors. Now, not all transitions we can see with just our eyes. For some, we need special equipment, like, for example, some transitions happen in the ultraviolet range. So the energy that is given out by electrons is in the ultraviolet range, and we can't see ultraviolet wavelengths without special gear. And some transitions give out infrared wavelengths, and we can't see that without special gear either. The only one we can see is the energy that is given out in the visible region. So that is the colors we can see, like red, orange, blue, yellow, etc. Now, it is a bit complicated to understand everything. So I'm not going to get into the specifics of what's going on there. I'm just going to look at this particular question. I'm going to explain it to you based on that. So the general term is that energy actually increases this way. So these lines, each of these lines corresponds to an electron transitioning from a higher energy state to a lower energy state and giving out some energy. Now, the energy that is given out from some transitions is greater than the energy given out from other transitions, as you can see. So this way, the arrow that I've drawn is increasing energy. That would mean that R, line number R, has a higher energy than line number M. And we talk about energy in this in terms of wavelength. So this is a wave. Energy is given out in the form of a wave. And waves which have higher energy tend to be more squished, you could think. That means the wavelength is shorter. So waves with higher energy tend to look something like this. For all the physics student out there, I don't know physics, I haven't done it. So I'm just going to be talking about it from a chemistry point. I may get some terms of it mixed up, but please forgive me for that. So this would be a high energy wave, and this would be a lower energy wave. Now, as I said, energy increases from left to right on a emission spectrum. That means R has higher energy than M, and Q has higher energy than P, for example. Now, option A in the MCQ tells us that line M has a higher energy than line N, and that's wrong, right? Because we have said that energy increases from left to right. That means the electron transition, which was responsible for the emission at line number N, so this particular emission over here, the energy in this emission is higher than the energy in this emission, because as we can see, energy increases from left to right. So N actually has a higher energy than M. That means this is automatically wrong. Let's look at option number B. So line N has a lower frequency than line M. Now I want you to remember a very general rule. If you're not a physics student like me, I just want you to remember something. So higher frequency is equal to higher energy. Likewise, smaller wavelengths is equal to higher energy. That's all you have to remember. I just want you to remember this. Higher frequency means higher energy. Smaller wavelengths means higher energy. So when they say that line N has a lower frequency than line M, that is wrong, because we know that line N has a higher energy than line M. This would also mean that line N would have a higher frequency than line M, because higher frequency is equal to higher energy. So option B is automatically wrong. Let's take a look at option C. Line M has a longer wavelength than line N. And well, wait a minute. We said that smaller wavelengths is equal to higher energy. If a wavelength is long, this means that it doesn't have that much energy. And we know that M has a smaller amount of energy than N. So this does seem correct, right? Because if M has a longer wavelength, that means that it has lesser energy. And according to our emission spectrum, M does have lesser energy than N. So yes, C is the correct answer. And what about D? D says lines converge at lower energy. And this is false. The truth is that lines converge at higher energy. We can see over here in this emission spectrum, as we increase energy, these lines, they're coming closer and closer and closer together. And eventually they will come so close together that they form a continuum. So it kind of looks like just one continuous color. So if you go on and if you search it up, you'll see what I mean. So these lines actually converge at higher energy, not lower energy. So that's why this is wrong. So the correct answer is C. I hope you understood this concept of emission spectrum. You don't have to know much about it. It's a very small part in topic 2, but they ask a lot of questions. So make sure you know the basics. I think this video should prepare you for any kind of questions you may come across for emission spectrum. I've also made other videos on emission spectrum before, which requires you to make a few calculations, but that is only for HL. This is for both HL and ASL. So please make sure you study this topic. Thank you so much for watching. If you want to know more about it, please look at the Cambridge textbook. I have a link. I will provide you a link to it if you DM me, and I will be more than happy to share that with you. So thank you so much for watching. Take care of yourselves, and I'll see you in another video with another question. Goodbye.